All right, page 706 today. We are going to be working with and talking about measuring angles and arcs. Measuring angles and arcs. So, a central angle. A central angle of a circle has its vertex on the center of the circle. So if we've got circle B, and then we draw an angle inside this circle, this is angle ABC. The vertex of the circle is on the center. Then we have a central angle. All right, angle ABC is a central angle. So we're going to say the sum of the central angles of a circle is 360 degrees. The sum of the central angles of a circle is 360 degrees. So let's draw another circle here. And in this picture now we have three circles, or I'm sorry, three central angles. They all have a vertex on the center. We got angle 1, angle 2, and angle 3. All right, the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 360 degrees. So some of the problems that you'll see today will look like example 1 there. And we've got this going on. All right, so in this case, we've got three angles here that all have to sum 360 degrees. One of the angles is 130 degrees. Of course, this angle is 90 degrees. It has the 90-degree symbol in it. So you can find the measure of angle X by taking the measure of angle X is equal to 360 minus 130 minus 90. So 360 minus 130 minus 90 is 140 degrees. Example 1A. We've got a 145 degree angle and a 165 degree angle. And we've got X degrees here. So we can say that our X is equal to 360 minus 145 minus 160. Yes. The book says 165. I wrote 160. We'll go with 160. Oh, I wrote two different numbers, didn't I? Sorry about that. Yeah, let's make that a 5 over here. So 360 minus 145 minus 165. 50 degrees. All right, any questions on that? The sum of the central angles for a circle is 360. All right, bottom of page 706. An arc. Is a portion of the circle defined by two endpoints. So if we've got another circle here, circle B, and then we've got a central angle, central angle ABC intersects arc or intercepts arc AB. This right here is an arc. Now, an arc can have a length and it can have a measure, a degree measure. Okay. So if you see, this reads the measure of arc AB. That's in degrees. This would be read as the length of arc AB. So the measure of arc AB is in degrees. And if there's no cursive lowercase m, then we're talking about the length of the arc AB. And the length is going to be in whatever unit measure the problem, or whatever unit measure the radius and or diameter. Okay, so the length in same unit measure as the radius. Now on the top of page 707, we got three types of arcs to talk about. We've got a minor arc. Is the shortest arc connecting two endpoints. So back to this circle again. Circle B. With endpoints A and C. Here's AC. Arc AC. Minor arc. Shortest distance from point A to point C. Minor arc. Now, do you see the other arc in this picture? We're going to put it around this backside. I'm going to put point D right here. And I'm going to color this green. So we've got another arc in this picture that goes around. That's even on the line. Goes around the backside of this circle. That green arc there is a major arc. Major arc. The longest arc connecting 2 points. And then a major arc is the longest arc connecting 2 endpoints. We describe major arcs, or we named by 3 points. So this major arc, we would call it arc ADC. You could also call it arc CDA. That means we're starting at A, we're going through D to get to C. Because if you've got a circle and you don't have anything labeled other than the points on the circle, if you see 3 points naming the arc, it's typically going to be a major arc. You start at the first point, you go through the second point, and the arc ends on the third point. So a minor arc is typically named by 2 points. All right, so we would call this arc AC or arc CA. And last is a semicircle. A semicircle is an arc with endpoints on the diameter. So right here we've got circle, center, it's got a chord. Chord happens to go through the center, so we've got a diameter. So here's our semicircle. Starts at A, goes through D, ends up at C. Now, the measure of a straight line is 180 degrees. So the measure of arc ADC equals 180 degrees. Then we're going to go back to this minor arc and this major arc. Minor arc AC or CA is named by 2 points. Its measure is equal to the central angle. Minor arc's measure is equal to the central angle. So this blue angle right here, if this is 95 degrees, this central angle measures 95 degrees, then the measure of arc AC is equal to 95 degrees. All right, that's this blue portion. That's 95 degrees. So if the minor arc AC is 95 degrees, if we take 360 and subtract the 95, we get 265. So that means this back angle is 265 degrees. So the measure of this major arc, the measure of arc ADC is 265 degrees. Everybody okay with that? All right, so let's look at example 2 on page 707. And we've got this circle. Circle K. With points G and J. We've got KH. We've got point L. And we are told that this angle GKH is 122 degrees. So the first thing we're going to do is find the measure of arc GH. The measure of arc GH is the same as its central angle. So arc GH is 122, isn't it? The measure of arc HJ. All right, so the measure of arc HJ, this blue arc right here, is going to be the same as this central angle. And this central angle is a linear pair with 122, isn't it? So we're going to take 180 minus 122. That's 58 degrees. So if this central angle in here is 58 degrees, then the measure of arc HJ is 58 degrees. Now we need the measure of arc GLH. We're starting at G. We're going through L. And we're ending up here at H. So we're going semicircle. And then we're taking this blue arc and adding it to it, right? So remember, the measure of a semicircle is 180 degrees. So the green portion, the semicircle portion, is 180 degrees, isn't it? And then we've got this other 58 degree portion that we have to add. So the measure of GLH is going to be equal to 180 plus the 58. So 238 degrees. All right, if we had to classify these, arc GH, is that minor or major? Minor. HJ, it's minor. GLH, it's major. And arc GJ, what do we call that one? Very good, semicircle. All right, so take a look at the top of page 708. Now we're going to find some arc measures using percentages. All right. And what we've got here in this circle is a big pie chart. And we've got point A, B, C, D, E, and F. And this pie chart is just made up of a bunch of central angles. But you're given the information now in percentages. So this pie piece described by FA takes up 14% of the circle. And so does soccer, just below it. And then softball is 16%. We got volleyball at 18%, track and field at 18%, and basketball back to 20%. Female participation in sports. Refer to the circle graph, find each measure. Now, we're looking for the measure of arc, CD. All right, C to D is right here. It takes up 18% of the circle. All the way around the circle is 360 degrees, isn't it? So we need 18% of 360. So we take 360 times 0.18. And we get 64.8 degrees. All right, that's how we're taking a percentage of the circle and transferring it to a degree measure for an arc. The measure of arc BC. Why did they ask the same question twice? Let's not make it BC. Let's change that. Let's go B. Let's go BF. BF, still a minor arc. We're starting at B. We're going shortest route to F. It's this arc in green. So we take the sum of the two percentages. So in this case, we're going to take 360 and we're going to multiply it by 0.34. All right, because 14% plus 20% is 34%. So 360 times 0.34, 122.4. Now we're in degrees, okay? Arc BF measures 122.4 degrees. Everybody okay with that? All right. Take 360, multiply it by the percentage portion that your arc occupies in the circle. Any questions? Central angles, minor arcs, major arcs, semicircles, and finding their measures. All right, page 710. Your practice today is on page 710. 12 through 24.